Hey everybody, this is Mr. McKee with SEC210. I'm going to be going over lab 12.2.1.5, which is convert data into a universal format. Alright, I am going to do this from NetLabs, so if you guys want to log into NetLabs, that's great. If you don't, or you're going to use your the VMs that you've downloaded from Metacad, you're going to need the Security Onion VM, and you're going to need your CyberOps workstation. Alright, and let me go ahead and go. What I'm going to do to make it easiest to follow is I'm going to undock the Security Onion, and I'm going to undock the workstation. I'm going to tile these two, and then I'm just going to read the instructions. See if this works. Alright, that one, that one. Alright, cool. So I got Security Onion on the left, CyberOps workstation on the right. Alright. So what we got? We're going to normalize timestamps in a log file, normalize timestamps in an Apache log file, which is web server log file preparation in Security Onion. All right, and just so you guys know, all right, this is our topology. All right, so we got network. This is like our inside LAN. Security Onion is our firewall. It's got 3 interfaces. .1 is our interface for inside. We're not going to use that machine. We're going to use CyberOps workstation. There's our inside network. There's our DMZ network, which we're not really going to use, I don't think. And then outside, like our Kali Linux box, and then outside to the internet. These machines are not set up to actually connect to the internet. I have the virtual switches are not connected to the internet for obvious reasons. I don't want anybody downloading something. Alright, so that's what we're looking at. Let's go ahead and go back to the Security Onion and CyberOps. So I'm going to go ahead and log into CyberOps. Alright, there's our CyberOps. It doesn't look that great at the bottom, but we'll work with it. Alright, so this lab will prepare students to learn where log files are located and how to manipulate and view log files. Log entries are generated by network devices, operating systems, applications, and various types of programmable devices. A file containing a time sequence stream of log entries is called a log file. By nature, log files record events that are relevant to the source. The syntax and format of data within log messages are often defined by an application developer, and they're not standardized, which is hard to view a lot of times. Therefore, terminology used in the log entries often vary from source to source. For example, depending on the source, the terms login, log on, authentication event, and user connection may all appear in log entries to describe a successful user authentication to a server. This is often desirable to have a consistent and uniform terminology in logs generated by different sources. This is especially true when all log files are being collected by a centralized point. The term normalization refers to the process of converting parts of a message, in this case a log entry, to a common format. In this lab, you will use command line tools to manually normalize log entries. In part 2, the timestamp field will be normalized. In part 3, the IP version 6 field will be normalized. And note, while numerous plugins exist to perform log normalization, it is important to understand the basics behind the normalization process. And by doing various capture the flag events, yeah, log files are hard to standardize. If they're standardized, you save a lot of time. All right, we're using CyberOps Workstation VM and Security Onion VM. All right, normalize timestamps in a log file. Timestamps are used to log entries to specify when a recorded event took place. While it is best practice to record timestamps in UTC format, the format of the timestamp varies from log source to log source. There are 2 common timestamp formats known as Unix Epic and Human Readable. Unix Epic timestamps record time by measuring the number of seconds that have passed since January 1st, 1970. Yeah, so that might be a little bit difficult for a human to read. Human readable timestamps, on the other hand, record time by representing separate values for year, month, day, hour, minute, and second. All right, human readable, like Wednesday, 29 June 2017 at 13:27. Greenwich Mean Time. Timestamp is the same as a whole bunch of letters in Unix epic. All right. Anyways, from a programming standpoint, it is easier to work with epic as it allows for easier addition and subtraction operations. Yeah, for programmers it is easier. From the analysis perspective, however, human readable timestamps are much easier to interpret. Converting epic to human readable timestamps with AWK in Linux. Alright, AWK is a programming language designed to manipulate text files. It is very powerful and especially useful when handling text files where the lines contain multiple fields, separated by delimiter character. Alright, looks like a pipe in this case. Log files contain one entry per line and are formatted as delimiter separated fields, making AWK a great tool for normalizing. Alright, consider the application x underscore in epic log below, which I'll show it to you. Alright, this is what it's talking about. Alright, there's log file. The source of the log file is not relevant. Alright, that's one entry. Alright, one line separated by pipes. Alright, the log file above was generated by application X. The relevant aspects of the file are the columns. The columns are separated or delimited by a pipe character. Therefore, the file has 5 columns. The third column contains timestamp in Unix epic. Alright, right there. Alright, the file has an extra line at the end. This will be important later in the lab. Assume that the log analyst needed to convert the timestamps to human readable format. Follow the steps below to use AWK to easily perform the manual conversion. Launch the CyberOps workstation VM and then launch the terminal window. Use the change directory command to change to this lab.support files directory. A copy of the file shown above is stored there. Let's look at what they're talking about. Alright, so we're in there. We're going to open a terminal. Alright, so change directory lab. Alright. Oh, I'm jumping ahead a little bit. Let me get back. Whoops. And just to let you guys know, that is actually a lowercase l. That's not a 1. If you put 1 in, you're going to get an error. Alright? Remember in Linux, case sensitive. Alright, so this is showing, permissions in all of our files. Alright, so we're looking for application X in epic log. Alright, there's our log file right there from 2017. Alright, what we got here? Alright, so issue the following AWK command to convert and print the result of on the terminal. Alright, so I wish I could copy and paste this, but AWK begin space curly brace fs equal. Man, I would love to have to copy and paste this. Equals OFS equals parentheses pipe alright, curly brace on the end, another curly brace, $3 equals strf time, which I've seen that time format before when I was doing some programming. Alright, percent C that $3 parentheses curly brace print, brace on the end. Alright, application log. Okay, and if I get this right the first time, it's going to be a miracle. Alright, let me make it a little bit bigger. All right, so AWK space begin fs separating it by that. Let's hit enter. Oh man, okay. So now what it's done, it has converted from Unix Epic to human readable. Monday, 18 August 2008, 11 o'clock Eastern Daylight Time, which is where I'm at. All right, so this looks kind of like, you know, obviously the year's off a little bit. All right, this is a good, this tells you the structure of it. All right, it's formatting it. Oh, you saw my answers. That's not good. All right, that's fine. I won't take that out. All right, so were the Unix Epic time stacks converted to human readable format? Were the other fields modified? So you can look at it, 2Z, all right, that was changed, AF0. So the only thing that was changed was the timestamp. All right, compare the contents of the file and the printed output. Where is the line? Why is there a line? All right, so this will be tough to figure out. The reason for the extra line is because the file has an empty line at the end, which has led the script to mistakenly interpret it as 0. All right, remember this is counting from 1970, so actually 31 December 1969. And let's see, it automatically adjusts for the time zone, so UTC -5 is where I'm at right now, so that actually would be 12 o'clock UTC. All right, so that answers that. All right, use nano to remove the extra empty line at the end of the file and run the AWK script again. So what we're going to do is open up our text editor of application X _ N _ epic log. All right, so that's right there. All right. So Control X. Yes. Enter. Rerun this. All right. So it has space at the end that it interpreted as 0, as where it was starting at 1970. All right. With the time change, that was that. Took it out. Now you only have 1, 2, 3, 4, 5, 6 entries. All right. So the question is, what was printed by the command line? I'm sorry, I'm a little bit behind. Let's see. Okay, is the output correct now? Yes, the output is correct. While printing the result on the screen is useful for troubleshooting the script, analysts will likely need to save the output to a text file, redirect the output of the script above to a file name, application X in human.log. Okay. All right, so what we're going to do is we're saving the current file. Let's see, we're saving this file to, where are you at? So we're saving this, whoops, to application uppercase X underscore N underscore human dot log. Okay, so it saved it. It asks us what was printed by the command above. Nothing was printed out. It's talking about actually displayed on the in the terminal. Nothing was displayed. This is normal. All right, and let's see what we got. Use cat to view the application X in human log. All right, so let's go ahead and view it. Cat application X in underscore human dot log. All right, so we're showing that. That's our new file. Human readable format without that extra line. Okay, so we're good. And that is all of part 1. All right, similar to what was done with application X in Epic log file, Apache log files can also be normalized. Follow the steps below to convert Unix Epic to human readable timestamps. Consider the following Apache file, Apache and Epic log. All right. So let's see. We're still in that same directory. We're going to cat Apache All right. So this is a web server log file. People are requesting, that website, those websites. All right. So the Apache log file all above contains 6 entries. So I see 1, 2, 3, 4, 5, 6 entries. All right. Which record events related to the Apache web server. Each entry has 7 fields. The fields are delimited by a space. All right, so you see spaces in there. I guess I could make this a little bit bigger. All right. Kind of like that. Yeah, I wish I could make this bigger. That's a little bit better. All right. So you see that? There's spaces in there. All right. First answer to the question below. These are crucial for the construction of the script. In the context of the timestamp version, what character would work as a good delimiter character for the Apache log file above? Well, a space character. How many columns does the Apache log file above contain? Should have 7. In the Apache log file above, what column contains the Unix Epic timestamp? There's your timestamp right there. So 1, 2, 3, the 4th one. All right. In the CyberOps Workstation VM terminal, a copy of the Apache log file Apache in Epic log is stored in the Home Analyst lab.support.files folder, which we're in right now. All right. Use the awk script to convert the timestamp field to a human readable format. Notice that the command contains the same script used previously, but a few adjustments of the timestamp field and file name. So probably the easiest way to do this is do the up arrow to go back to that in our history. All right, so we're going to have to do what we got here. We're going to take out this. this is going to be 4. These numbers are referring to the fourth column, the fourth field. Alright, so take the fourth field out there. Time C. Alright, 4. Curly brace. Let's see. Print, curly brace. Whoops. Dang it. I hit enter. Alright, that's. Alright, let's try this again. Alright, we're there. Print. Alright. And home. List. Support files. Apache. And log. Syntax error near unexpected token. Yeah, I was figuring that was going to happen. Alright, awk begin fs ofs. Oh yeah, that's the problem. Yep, we don't have a pipe delimiter, so we have. Let's see what they got. Okay, so they got just nothing. Space. That should work. I don't even want to touch this thing until it gets to the end. Alright. Alright, what's your problem now? Alright, so begin fs equals. Oh, I know why. I think that needs to be actual space. fs equals ofs space. Alright, for string f time colon $4 that print yep, has that colon there. Oh, great. Alright. Let's take all this out. Okay. AWK begin. Alright. All that's good. And home. Analyst. Oh yeah, it's working now. Usually if you're typing something wrong, you hit tab when you're starting to fill in directories. If it's not auto-populating that directory, probably something's wrong. Apache. Okay, so I'm thinking that's good. Alright, cool. So, yeah. All those other things I typed, don't use that. Alright, now it's human readable format. Looks great. Of course, everything says, was the script able to properly convert the timestamps? No, because they're all midnight. Alright, for Eastern Standard Time. Alright, that's normal though. Before moving forward, think about the output of the script. Can you guess what caused the incorrect output? Is the script incorrect? What are the relevant differences between the application in Epoch and Apache in Epic? Alright, to fix the problem, the square brackets must be removed from the timestamp field before the conversion takes place. adjust the script by adding 2 actions before the conversion. All right, we can do that. All right, so right here, you put a curly brace, G sub, parentheses, that, bracket, is that a pipe? And then a backslash, bracket, /. All this is in the instructions, so don't freak out if you're like, I don't know how to do that. All right, equals 4. $4. All right, parentheses, curly brace. All right, so all that. All right, so all could begin looking for our delimiter, G sub. Let's see, G sub / bracket /. Okay. Oh yeah, crazy. All right, so that's there. Notice that after specifying space is delivered with. All right, so let's see. Okay, so from looking through here a little bit more, the problem was when we first did the, let's see, let's look back here. All right, so see these times, or dates rather, are not in brackets. These are in brackets. So take it out of the brackets first, which we did that. And I know there's a whole bunch of stuff there. All right, so remove the brackets. All right, print that out. And now right now, which is kind of confusing in the instructions, if you go and take this, let's see. So we remove the brackets, assume the 0. So the brackets were throwing it off. All right, so we took it out of brackets there. And if we go, right now it's going to show 2 entries for everything because we're printing out an entry right there. There's one print, or there's one print here, print here. So I'm going to do that. I'm going to do a clear. All right. So right now the way we have it, we have 2 entries for every time somebody tried to get something from this web server. And if I can get my mouse to work, all right, let's up arrow. Come on. Come on. All right, there we go. All right. So get back here and take this out. And if you see right here, the first one's the one that works. Where's it at? Let's clear it again. Alright, let's do this. Alright, there we go. Alright, so if we take out this first one, well, let's take the second one out. Alright, so that prints only the Unix epic. Let's go back. Alright, so following down the instructions, actually, we're going to have to leave it like that because what it's doing first, the first part of the expression is turning it into, removing it from the brackets, from the Unix epic time. And the second entry, like you can see right here, that's epic time, this is human readable time, and it just says leave it like that. I guess it's more trouble than it's worth filtering out that. I was trying to do that, but alright, so was it, and this is, let's see, part 2, number F. Alright, was the script able to properly convert the timestamps this time? And yes, but there's two. It was able to do it, but there's 2 entries for every time it accessed the server. That's fine. Alright. So log preparation in Security Onion. Because the log file normalization is important, log analysis tools often include log normalization features. Tools that do not include such features often rely on plugins for log normalization and preparation. The goal of these plugins is to allow log analysis tools to normalize and prepare the received log files for tool consumption. The Security Onion appliance relies on a number of tools to provide a log analysis services. ELSA, Bro, Snort, and Siegel are arguably the most used tools. And ELSA is enterprise log search and archive. It's a solution to achieve the following: normalize, store, and index logs at unlimited volumes and rates, provide a simple and clean search interface and API, provide an infrastructure for alerting, reporting, and sharing logs, control user actions with local or LDAP or Active Directory based permissions, plugin system for taking actions with logs, and exists as a completely free and open source project. Bro is a framework designed to analyze network traffic and generate event logs based on it. Upon network traffic analysis, Bro creates logs describing events such as the following: TCP, UDP, ICMP, network connections, DNS activity, FTP activity, HTTPS, requests and replies, SSL and TLS handshakes. Right. Snort and Siegel. Snort is an IDS that relies on predefined rules to flag potentially harmful traffic. Snort looks into all portions of network packets, headers, and payload, looking for patterns defined in its rules. When found, Snort takes the action defined in the same rule. We've already did that one time. Siegel provides a graphical interface for Snort logs and alerts, allowing the security analyst to pivot from Siegel into other tools for more information. For example, if a potentially malicious packet is sent to the organization web server and Snort raise an alert about it, Siegel will list that alert. The analyst can then right-click that alert to search the ELSA or BRO databases for better understanding of the event. Directory listing may be different than the example shown below. All right, so switch to Security Onion, and we're going to clear all this out. Boy, that was fun. Clear. All right. So let's go to this one. And my login is analyst, CyberOps. Make this a little bit bigger. That didn't look bad at all. All right. So open the terminal window in this Security Onion. All right, what we got? Oh, and you can right-click the desktop too for your terminal. All right, but you got to click that little button right there. All right. So ELSA logs can be found under the NSM/ELSA/data/ELSA/log directory. Change the directory using the following command. So we're going to use the change directory to the NSM ELSA data ELSA log. Whoops, and spelling is a good idea. All right, let's list. Whoops. There we go. All right, so let's see what we got. We got a bunch of logs in there. Web logs, search logs, query logs, node logs. All right, bro logs in Security Onion. Bro logs are stored at NSM bro logs. As usual in Linux systems, log files are rotated based on date, renamed and stored on a disk. The current log files can be found under the current directory. From the terminal window, change the directory using the following command. So we're going to change the directory to NSM bro logs and current. And let's list all of that. All right, so there's all our logs. All right, and then Snort logs. Let's change the directory to NSM sensor data. All right, LSL. All right, so those are our logs coming in from all our interfaces. 4 interfaces. All right. All right, so while the NSM directory stores some log files, more specific log files can be found under the var log NSM change directory and use the change directory and use the ls and l command to see all the log files in this directory. This is why I did this lab, because this lab is a bit confusing. NSM. All right, so let's list. All right, a whole bunch of logs. All right. All right, so notice the directory shown above also contains logs used by secondary tools such as OSEC, Pullpork, Phoenix, and Squirt. Phoenix, what was the other one? OSSEC, things like that. All right. And take some time to Google these secondary tools and answer the question below. For each one of the tools listed above, describe the function, importance, and placement in the security analyst workflow. And you can just Google that. All right, so log normalization is important and depends on the deployed environment. Popular tools include their own normalization features, but log normalization can also be done manually, like we did. When manually normalizing and preparing log files, double check scripts to ensure that the desired result is achieved. A poorly written normalization script may modify the data, directly impacting the analyst's work. So that was a lot to do. You know, it keeps telling you there's plugins that help you normalize the data, but like the National Cyber League, when I did that this year, I mean, the log files were like the most difficult thing to look through. And they weren't normalized, but if you know how to do that, you can save yourself some time and anguish. All right, and that's it. Just go ahead and answer all those questions listed. There's, let's see, one, I'm counting them up, 2, 3, 4, 5, 6, 7, 8, 9, 11. Looks like 11 questions. All right, this video went way long, so that's it. Thanks for watching. I'll make one more video for this week's final lab.